LCM, or least common multiple, for large numbers. Let's start by defining this. The least common multiple is the smallest number that is divisible by a set of numbers. This basically means that, say if I have a set of numbers 3 and 5, what number that's a multiple of these numbers can be divisible by both? Let's look at a few examples. In our first example, I have 2, 3, and 4. These are relatively small numbers. I think of these numbers as numbers that are common as denominators in fraction problems. In this case, it wouldn't really make sense to go through the process of prime factorization, which we'll do later. We would simply skip count by the largest number, and this would help us find the least common multiple the most effectively. So 4, 8, so we get to our third multiple here, and I know that 12 is also a multiple of 3 and 2, so we're done. Now we use a different method for finding the least common multiple of larger numbers. This method focuses on using prime factorization. We're going to break the numbers apart into their smallest factors to find everything that they have in common. This is by far the most effective and quickest way to make things happen. So let's look at example 1. Our first step here is to find the prime factorization of the numbers. And I'll do that now. The second step is to identify the common prime factors. In this case, both numbers have a 5 in common. Now, we look for the greatest amount of a prime factor in an individual number. So now I'm looking at what the numbers don't have in common. So we have an extra 5 here, so we add that in, and an extra 3 here, so that gets added to the mix. And then finally, the product of steps 2 and 3 is the least common multiple. So my 5s that we have in common, and then the ones that are left out. And that gives us 75. So 75 is our least common multiple. I'll walk through this process with 2 more numbers, or sets of numbers. So now we have 18 and 24. So first step is prime factorization. Now that we have the prime factorization, we look for common factors. So 18 and 24 have a 3 in common. They also have a 2 in common. Now I look and there's an extra 3 and 2 more 2s. If I multiply all of these together, I'm going to get the least common multiple. In this case, the least common multiple is 72, or 9 times 8. Example 3, 20, 50, and 125. Again, the first thing I do is I find the prime factorization. Now that I have the prime factorization, I like to write these out so that I can really more easily compare them. If you'd prefer to leave things in the factor tree, that's fine too. So now I look and 20 and 50 have a 2 in common, but not 125. So it looks like there are only 5s in common. So we've got 1 5 in common with all of them. Now I'm going to look, and there are 2s as factors in 20 and 50. I have to go with the set that has the most. So I have to use both 2s. Now when I look at the 5s, there's 1 5 that's an additional factor for 50, but 2 for 125. I have to use both 5s. So I'm going to look at this as 10 times 10 times 5. So that means my least common multiple here is 500. I hope that this has been informative, and I look forward to your feedback.